Pi is easy to picture with Archimedes. Polygons inside and outside a circle, squeezed towards the circumference. Great geometry, great intuition, but terrible for extreme precision on a computer. So today, we take a different path. Euler gives us the method. Rabinowitz and Wagon give us the algorithm. And instead of floating point, we stay with a pure integer arithmetic. This is our starting state. Down here on the floor are 84 blue bars. That is our remainder array. Every single one starts at 2. On the left is the accumulator tank. That is where the running state of the computation lives. And in the back is the result table. That is where the extracted digits of pi will land. Let's fire the engine, working its way backwards from position 84 down to 1. At every bar, the same 4 things happen. The odd divisor sets the modulo boundary, that's the glass tube. The orb crushes the bar down to its remainder, that's the extraction. The gear spins and multiplies by position, that's the multiplier base. The extracted value is pushed into the accumulator tank, that's the transfer. Extract, divide, multiply and transfer, over and over. And that little pink orb hovering over the sweep, that is our running accumulator, carrying the state of the whole computation as we move left. This is the key idea. We are not approximating a circle anymore. We are not measuring geometry. We're just moving exact integers through a machine. The inner loop is complete. The tank is full and boom, it fires a projectile straight into the table in the back. This is where we divide by 10,000. The whole number becomes our first digit of pi, the number 3. The remaining fluid in the tank stays behind. That is our carry for the next round. So every path does 2 things at once. It extracts a visible digit and it preserves the leftover precision for the next pass. Round 2. The outer loop triggers again. The sweep orb resets, but it does not go all the way back. Our working range shrinks by 14 bars every pass. Tank drains, artillery fires, 1, 4, 1, 5. We are generating pi on the table. Notice how the golden pillars physically grow their exact values. A 9 is tall, a 1 is short. Watch the table in the back. Because it sits lower, you can see the new digits popping up and spinning like mechanical counter, while the orb is still calculating on the floor. This is why the Spigot algorithm is so beautiful. It is not approximating a circle anymore. It is just doing exact integer work. Extract, remainder, multiply, carry, and fire. And remember how absurdly fast this really is. On a modern CPU, I tested in mine, the full 20-digit computation finishes in about 500 nanoseconds. So in that time, light only travels around 150 meters. So what you're watching here is not the real speed of the computer. It is a massive, slowed-down explanation of an event that is almost instantaneous. The loops finish. The floor powers down, the calculation is complete, and there it is, resting on the table. 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 3, 8, 4. 20 perfect decimal places of pi, generated entirely by extracting and carrying remainders. Euler gave the method, Rabinowitz and Wagon gave the algorithm, and this machine let us watch it think. The Spigot algorithm. Thanks for watching.